This is Liliana Beltran from the Department of Architecture at Texas A&M University. Today I will present the design of a zero-net carbon house located in a hot and humid climate. The design integrates multiple passive environmental technologies to reduce the energy consumption, maximize thermal and visual comfort, as well as improve occupants' well-being. The house is located in the city of College Station, located in Central Texas. The site is within an infill urban neighborhood, as it's shown in here. The area of the house is 158 square meters with a detached garage of 56 square meters. College Station is located in climate zone 28, and we could see here the precise location in this US map. Current EPW weather files were morphed to represent the years 2020, 2050, and 2080. We could see here an increase of the highest dry bulb temperature from 37 degrees Celsius in 2020 to 46 degrees in 2080, as well as an increase of the lowest dry bulb temperature of 17 in 2020 to 22 in 2080. The cooling degree days in 2020 are also increased by 50% in 2080, while the heating degree days are reduced by 49% in 2080. Here is a comparison of the Universal Thermal Climate Index, or UTCI, for the year 2020 and the year 2080. We could see that the overall heat stress is higher while the cold stress is reduced, comparing these 2 years, and the neutral thermal stress hours are down by more than 24%. So this is an indicator of how heat stresses our human body induced by a set of climatic conditions like air temperature, humidity, wind, and radiation. The house has a rectangular layout along the east-west axis within a trapezoidal lot of 906 square meters. The house, which we could see in this image, under construction, and it's 17 degrees east of north. That's the main axis of the house. This was done to follow the constraints of the site. They were in close proximity to the neighbors, and also the idea was to maximize the green area towards the southern part of the lot, where there is an old post oak tree. So all the green area is towards the back. Multiple design strategies were incorporated in this house. As we see here, the building is, or the house is organized in around 2 buildings. The main living conditioned area is oriented towards the north and south, and the detached garage is designed to cast shadows to the main living area. The design integrates multiple technologies that include an optimized shape for shading and natural ventilation during the cooling season, as well as passive heating for the coldest months. Most of the windows are south-facing with minimum openings to the east and west. Window views are oriented to outdoor green areas to provide health benefits to the building occupants. High-performance materials were selected to minimize heat transfer through windows and envelope. The house is designed as an all-electric home with on-site renewable energy. Here are the floor plan distribution of the house. The house is one story, and it follows the universal design principle. So that means that people of any age can occupy the house. The living spaces are mostly facing south, and while the more service areas, including a mechanical room in this section, are towards the north, and they are mostly illuminated by smaller skylights. The house has brick and stucco exterior walls, a metal panel roof, and cathedral ceiling. This is a wood construction with 2x6 studs and use rigid insulation in walls and roof. Windows are triple pane with U values of 0.13 or R values of 8. These elevations show the openness of the house towards the interior south-facing green areas with minimum openings to the east and west. There is also this high wall that casts shadows onto the house. Horizontal global radiation was simulated during the design to verify the overshadowing design as well as to determine the best locations for solar panels. So you could see here in blue the areas that are protected from the harsh summer sun, and all coming through this garage, as well as we could see here the north facade, and the placement for best location for the solar panels on top of this south-facing roof. Airflow was evaluated using specialized software. These prevailing wind were simulated to measure or verify the impact of outdoor seating areas, especially in the interior porch during the cooling season. So the prevailing wind direction is coming from southeast, and we could see here highlighted in red the location of the porch. Here is another image showing the interaction of the wind around the house, and there are these south-facing windows that are opening for allowing cross ventilation throughout the house, and these would be used during the hours when outdoor conditions are comfortable with lower humidity levels. The windows are all casement operable windows that allows about a 90% of efficiency to move air into the house. The daylighting was also evaluated due to the nature of some of the spaces that will work as home offices. The spatial daylight autonomy, which is a metric used by LEED for regularly occupied spaces, we could see that it's getting to 100%. This means that more than 300 luxes for about 50% of the year would be reached in all these areas. The ASC, or annual sunlight exposure, would be minimized with shading design or overhangs that are along the south facade, and they are below the 10% required by LEED version 4.0. Luminance levels were also checked, as we could see in these images, during the noon hours on the equinoxes and solstices. And we could inspect here that values during all these hours would be above the 300 luxes, which was the target. Glare was also checked. There were no disturbing glare in the space. Only there are some small areas adjacent to the windows where an occupant would be seen through the windows at about 30 centimeters away from the window, which is normally an area where it's mostly occupied by desk or other furniture. So glare is gonna be towards for very few hours in these edges, and that will occur few days during the winter months. Circadian light also was simulated to show the benefits that occupants may have during the whole year. And in these images we are seeing during the equinoxes and solstice. And for the well rating system, it's required to have the equivalent melanopic lax for about 90% of the space or the area of that would be occupied, and that would be for between the hours of 9 and 1 p.m. So that's achieved in all the areas, the working areas or regularly occupied spaces, as well as the ratio of melanopic or photopic, which measures the alertness for occupants, were also verified, and it reaches to the requirements of the well rating system. Multiple simulation tools were used to assess the energy performance of the design, and also a series of parametric runs were done with different software to find the optimum properties of the materials to minimize or reduce the energy use intensity in the building. So it's reached in the final design EUI of 9 kilobtu per square feet per year, and that's considering just the baseline concept, and then adding the photovoltaic panels of 3 kW, that EUI is reduced to 0. And we could see here the comparison of the annual energy cost in before and after adding the renewable energy. The house is under construction, and you could see the different phases that it's shown in these images. It's going to be completed very soon. So it has been documented carefully, all the process, the construction process, so that the materials are used according to the specification of the design. In summary, we could say that the house performs better than the goal of the 2030 challenge for the year 2020, which is 12 EUI, or EUI of 12. The predicted EUI without the PVs is 9, so better than 12. And with 3 kW solar system, it will get to 0 net carbon. Daylighting has been harvested and modeled and measured, currently under measurements, and it will not need any artificial lighting during daytime hours throughout the year. There are outdoor seating areas also to prove the circadian light, not just within the building but on the surrounding areas of the house. There is a integration of the house to the side, to nature, views to outdoors from almost all interior spaces. This has been done with a team of participants that work together since the early stages, and it's still been done that way until the construction is finished. Thank you. Here is my contact information in case there is any question.